Hi again and welcome to a lecture on mechanics in which we will do a second example on hydrostatics. In this example, we have a future concrete retaining wall which is under construction. So first we have to build a system of forms in order to support the wet concrete which is like a fluid before it hardens up. So these are the forms here on the left hand side and on the right hand side of the future concrete wall. And on the right hand side there's a vertical form that is continuous, AB, continuous perpendicular to the page, so we can hold the concrete, the wet concrete. And this is supported by diagonal struts BC, which are attached to the ground at 0.8 meters from A at point C. And the total height of the future retaining wall is 1.2 meters. Now the braces BC are spaced at 1.6 meters perpendicular to the screen or to the page. So there is one brace at every 1.6 meters into the page and also at 1.6 meters out of the page along the length of the wall, which is again perpendicular to the page. The question asks us to calculate the force in each brace BC by knowing that the density of the wet concrete, which as I said is a fluid, equals to 2,400 kilograms per meter cubed. And also by knowing that the joints at A, B, and C are pins. So we only look at the right side of the concrete wall. It doesn't matter what happens on the left-hand side of the concrete wall. The pressure on AB will not be influenced by the width of the wall. So therefore, this is the form AB, which is acted upon by a linearly distributed pressure, which is 0 at the top of the fluid, at the top of the concrete at B, and has a pressure intensity small pc at point A. Small pc equals to rho concrete, the density of the concrete, times G times H, which is 1.2 meters, and that equals to 25.253 kilonewtons per meter square. Now, point A was a pin, so we can draw the reaction forces, AX and AY, and at B we have cut the strut BC, so then we have the axial force in the strut called FBC, making an angle theta with a vertical form AB. We can quickly calculate the angle theta from geometry, and hence it results equal to 33.69 degrees. Next, we need to calculate the equivalent concentrated force for this pressure block. So that equals to the area of the triangle multiplied by the length perpendicular to the page. So that would be the tributary width corresponding to each of the struts, so 1.6 meters. So we are in the third case of the three possible cases where we have repetitive elements. So here we have the struts repeating at every 1.6 meters. And capital PC, the concentrated force, is located at 0.4 meters from point A, from the bottom of the form. If we now sum the moments about A to eliminate AX and AY from our equation, then we can solve for the force BC. That would be the only unknown in our moment equation. And therefore, if we compute the numbers, the force in brace BC will be equal to 16.29 kilonewtons, and the member will be obviously in compression. So this was an example in which we had to deal with a long structure with repetitive elements, and we have to apply the concept of the tributary width. So thank you very much for watching this lecture, and I will see you at the next one where we'll do some more examples.